All right, everyone, this is Mr. Spiels again. Just wrapping up here with the last problem, number 42. So this is a big problem. It's got a lot of different aspects to it. We're graphing the rational function. Rational meaning you got a numerator, denominator, and it just kind of walks you through the steps here. We're going to go through one by one. Simplified function. Now, when you factor your original function and cancel out top and bottom, that's called your simplified function. This is already factored for you. All of these are factors, kind of like factored out. So what I'm going to do is I'm going to cancel out the common things top and bottom. So x plus 3, I'm going to cross that out because that's the same. So my simplified function would be y equals 2 parentheses x minus 2 on top, and then x minus 3 on the bottom. So that's the simplified function. Okay, so we're done with that one. Now, remember, we're graphing this. So a lot of times I just like to graph it in my calculator just to see how it looks before, I'm going to have to get more exact, but I just want to see the general shape of it, how it looks. So I plotted this simplified function in my calculator. You're going to have to be careful with parentheses, right, in front of the 2 at the very. So numerator has its own set of parentheses, denominator has its own set of parentheses. Hit graph. Now it looks to me like we're going to have some sort of asymptote kind of between these two curves here. Looks like maybe also a horizontal asymptote. So that just gives me a general idea of how it's going to look. So with that being said, we'll come back to that. Let's look for some holes in the function. So where are we going to have some open circles in this function? Well, that relates to, the holes relate to if there's a common factor in the numerator and denominator that you can cancel out. Okay, so in our case, x plus 3, we can cancel that out. That should tell you where the holes in the function are. So what you do is you take what you canceled out, which is x plus 3, and you want to set that equal to 0. And that's going to give you your x value where one of your holes is. So I have x equals negative 3. Okay? So I know it doesn't say here, but we want to have a coordinate point for this hole. Where can I mark an open circle? So at negative 3, I have to find what is that y value. So what you would do is you would take your negative 3, plug it back into your original function, and get your output, your y value. Okay, I'll save you guys a little bit of time here. You can obviously, you should try this on your own, but you should come up with 5/3. Okay, so at negative 3 comma 5/3, now 5/3 is a little bit more than 1, so I'm going to go negative 3 and 5/3, and I'm going to put an open circle. Okay, all right, just make sure I put that in the right spot. Looks good. Okay, so vertical asymptote. Now a vertical asymptote is always going to be wherever your denominator is equal to 0. You want to set that equal to 0, your denominator, and that's going to give you the x value of your vertical asymptote. So if I say x minus 3 equals 0, that means my vertical asymptote is at x equals 3. All right, always set your denominator equal to 0, solve, and that'll give you your vertical asymptote. So at x equals 3, I'm going to mark a vertical asymptote. Okay, kind of hard to see there. X-intercept, y-intercept. Now, these can be a little bit longer if you're doing them by hand. You can use your table and your graphing calculator to also kind of figure this out. But just as a heads up for future reference, to find your x-intercept, you set your y value equal to 0 and then solve for x. Okay? Now it's the opposite for your y-intercept. For your y-intercept, you set your x equal to 0 and solve for y. Okay, so you know what? Let's just do this. Let's just do one of them by hand so you can see what it looks like. X-intercept. I'm going to set my y equal to 0. So I'm going to say 0 equals. I'm looking back at the original function here. 0 equals, this is going to, let's distribute that just to make it easier to solve. So that's going to be 2x minus 4 in the numerator over x minus 3 in the denominator. Okay, so we want to solve for x because that's going to give us our x-intercept. So we can bring that whole denominator over. If we multiply both sides by x minus 3, it would cancel it out. Bring it over to the left side. Well, 0 times anything is still 0 equals 2x minus 4. Okay, the rest is just basic algebra from here. You add the 4 to both sides, you divide that by 2, and your final answer, when you get through all that, is 2 is equal to x. Okay, so your x-intercept is going to be 2 comma 0. Okay, so 2 comma 0 would be right there. I'm going to mark my x-intercept. Okay, another way you could have done it, a shortcut way of doing it, is to go in, you have your graph here, okay? If you go to the table and just find where is your y value equal to 0, right? You just did that over here. You set your y equal to 0. So where your y value is to 0, your x is equal to 2. So 2 comma 0. Well, that's what we just did. Okay, that's a quick shortcut. All right. Now, our y-intercept, let's just take that shortcut. So our y-intercept is going to be where we set x equal to 0 and solve for y. Well, x is equal to 0 right here. Solve for y, 1.33 repeating, is actually 4/3. So this is going to be 0 comma 4/3. Okay. Now let's see. We want to plot that, right? So 0 comma 1.33 repeating, or 4/3. That would be somewhere like right here. We're just plotting all these points. Eventually, we're going to connect them. Okay. All right. Last one, horizontal asymptote. Now, your horizontal asymptote, you kind of have to remember these rules. You have an exponent in the numerator. You have an exponent in the denominator. All right, these exponents are going to drive what your horizontal asymptote is. Okay, if the exponent in your numerator is less than the exponent in the denominator, your horizontal asymptote is at y equals 0. Okay, 2 more. If your exponent in your numerator is greater than the exponent in your denominator, your horizontal, or actually in this case, you don't have a horizontal asymptote, no HA. If the exponents in your numerator and your denominator are equal, then your horizontal asymptote is your leading coefficients. I'll explain what that means in a second, because that's actually our case, right? If you look at our simplified function, exponent is 1, exponent is 1, right? X to the first, x to the first. Okay, so we actually have this case down here. Your exponents are the same. So the leading coefficient is actually your leading number, like the number in front of your variables. So in this case, 2 over, you can put a 1 right here, right? There's no number there, so we're just going to put a 1. So 2 over 1, your leading coefficient is 2, so your horizontal asymptote is at y equals 2. So now at y equals 2, I'm going to write my horizontal asymptote. Just cross like this. Okay, now we're going to plot this, but we just want to make sure this looks the same as our graph. We've got a vertical asymptote. We've got a horizontal asymptote. It looks like right here, this is where we're going to connect the dots right here, right? That's going to be kind of this area right here. But we need a few values up here that we can connect. So again, let's go back to our table. And let's just pick a few points, like a few easy ones. So 4 comma 4, that'd be a good one. 4 comma 4. Here's another easy one. 5 comma 3, right there. Okay, that's probably good enough. So let's connect those. Remember, we don't want to cross our asymptotes. Put your arrows in, go on forever in both directions. Now this one, Just be careful here. I want to make sure I don't mess anything up. Don't want to cross my asymptotes, so I'm just going to have my arrow kind of going off in both directions. Okay? So that's what my graph of my rational function would look like. If I sped through this a little too quickly, obviously reach out, ask questions, and I can kind of walk you through a little more detailed step by step. Okay?